In this problem, I haven't told you to use polar coordinates, and I haven't described the region as a region that you should necessarily think about using polar coordinates. All I have is this integral here. And you could try to do this integral in Cartesian coordinates, but I think a good idea is to sketch the region and see if there's not a better coordinate system to work in. So let's look at the y integral. That's the outside integral. Y is going to go from 0 to 3 over the square root of 2. And for every fixed value of y, x is going to go from y to the square root of 9 minus y squared. So it's going to go from x is equal to y to x is equal to the square root of 9 minus x squared. Now the line x equals y is this line right here. But notice that x equals the square root of 9 minus y squared. That's just the circle of radius 3. So what we're saying is that for every fixed value of y, x goes from the line x equals y to this circle, like this. Now this looks like something that is easier to use polar rectangle or polar coordinates for. So let's use polar coordinates to do this integral. So again, we need a theta integral and an r integral. Theta is going to go from 0 to whatever this is. Okay, so it's going to go from 0 to whatever angle theta this is. Well, this is the line y is equal to 8, so that's pi over 4. So theta will go from 0 to pi over 4, and for every fixed value of theta, r will go from 0 to 3. And it's probably a good habit to get into to just write the r dr d theta. And now the function that we're integrating is cosine of x squared plus y squared. In other words, cosine of r squared. This is a u substitution problem. The inner integral is where u is equal to r squared. If u is equal to r squared, du is equal to 2r dr. And so this becomes, of course, the outer integral stays the same. It's 0 to pi over 4. And the inner integral, well, let's change the coordinates, or let's change the limits. U is going to go from 0 to 9. And the function that we're integrating now is cosine u du over 2, and then the d theta. This is equal to the integral from theta equals 0 to pi over 4. There's the 1/2 from the inner integral. The antiderivative of cosine theta is sine theta. So this is going to be sine of 9 minus sine of 0, so just sine of 9. D theta. And this is pi over 8 sine of 9.